First of all, it only applies if a function is continuous on an interval. And k is some number between f of a and f of b. This k is just a y value. So if you look at the graph here, this k is just some y value. It's some y value that I'm calling k. And k is between f of a and f of b. So my interval is a to b. These are the x values. So the output for a is f of a. The output for b is f of b. So what it's saying is that there has to be at least one number between a number x between a and b such that f of x is equal to k. So what that means is that growing scenario. You start off at 19 inches long. Let's suppose now you're 5 feet 3 inches tall. So you're ending here. You start at 19 inches, you're now 5 foot 3 inches tall. At some point in your life, you had to be exactly 3 feet tall. This is an example of doing the value system. So somewhere you can't go from being 19 inches tall to 5 foot 3 inches tall without some point in your life being exactly 3 feet tall. So what the intermediate value theorem is saying is that if you have a continuous function over an interval, there is at some point there is a y value that is between f of a and f of b. That's all the intermediate value theorem is saying. So what it's saying is that this. So over this particular interval, you've got f of a has to be less than k. You agree with that from this graph. F of a is less than k. F of b is greater than k. So when this happens, and we know that this function is continuous over the interval a to b, then there exists a value. Between f of a and f of b, where f of k is equal to k, or f of x is equal to k. When you're talking about the intermediate value theorem, you've got to always state a hypothesis and a conclusion. Always. The hypothesis is the function has to be continuous, and you must state that. All right? So, for example, here's examples involving intermediate value theorem. You have again, here's a cubic function. They want me to show that there is a number k such that f of k is equal to 10. So they may give you an interval, they may not give you an interval. This is a case where they actually want you to find the interval. So what we have here, remember, this is a y value. So I have a y value of 10. So I'm going to put a picture with what this is asking you. This is a cubic function. I know cubic functions, it's a polynomial function, so it's continuous for all real numbers, so it has to look something like this. So what I need to do is I need to figure out at what two particular x values would this f of k fall between. So here's my a, here's my b, that's what I want to solve. So really what I want to know, in terms of the intermediate value theorem, I want to be able to figure out where is f of a less than 10, where is f of b greater than 10, to find the interval. The way you find your interval is you simply make a quick little t-chart. So, well, 0 is obviously 0. So we start at 1. If I plug 1 into this function for x, what do I get? 1. You agree with me that's less than 10. Plug in 2. 2 to the third is 8. Minus 4 is 4. 4 plus 2 is 6. 6 is less than 10. You agree with me there? 3. 3 to the third is 27. Minus 9 is 18. 18 plus 3 is 21. Is 21 less than 10 or greater than 10? Greater than 10. So you agree with me then that f of 6 is less than 10. F of 3 is greater than 10. Oh yeah, f of 2. F of 2. Yes, f of 2. F of 2 is less than 10. So you agree with me that f of 2 is less than 10, f of 3 is greater than 10. Alright? So now this is how you'd write it. First of all, your hypothesis. You always have to state, always, calculus is not about answers. It's about conclusions and justification. Alright? This is your justification. So again, your hypothesis is f of x is continuous for all real numbers, because it's a polynomial function. Your conclusion is basically what you just told me. F of 2 is less than 10, and f of 3 is greater than 10. Therefore, by the IVT, there exists a number k in the interval 2 to 3, where f of k, it's brackets because they're including. I mean, it wouldn't take off if they were parentheses, but the interval's 2 to 3. Okay? So let's repeat what we just talked about. We've included f of 2 is less than 10, f of 3 is greater than 10, and we found that from the chart. So therefore, by your immediate value theorem, it's always a planar reduced immediate value theorem by the IVT. There exists a number k in the interval that you found where f of k is equal to 10. Okay? That's full of k. Yeah, you always do again. Okay? That's where sometimes they make you find the interval, sometimes they'll give you the interval. So any questions? Let's look at another one. So given h of r is a continuous function. So again, it's continuous. Explain why there must be a value r for the interval. So they're giving you the interval from 1 to 3, such that h of r is equal to negative 5, given that h of 1 is equal to 3, and h of 3 is equal to negative 7. So again, I'm just going to put this to picture for you. So they're telling me, they're giving me a point. I have this point 1, 3. I have this point 3, negative 7. It's continuous, they're telling me that. So I know there's no whole gaps or breaks from the interval 1 to 3. So they want me to explain why there has to be a value for r for which h of r is equal to negative 5. Remember, negative 5 is a y value. Again, you can't travel from a y value of 3 to a y value of negative 7 without passing through negative 5. Would you agree with me? Now, why is that? Well, first of all, h of 1 is what? That is larger than negative 5. So I know that h of 1 is greater than negative 5. I know that h of 3 is negative 7. Compared to negative 5, that is less than negative 5. So what is my hypothesis? Well, first of all, what are they telling about h of r? H of r is what? continuous. So telling you that, you have to state that again. The conclusion. H of 1 is greater than negative 5, and H of 3 is less than negative 5. Therefore, by the IVT, and really what your conclusion, you're basically going to restate what they're asking you to do. In your conclusion, you're basically restating this. So after you have to state this inequality, 1 less than, 1 greater than. By the IVT, there must be a value for R in your interval 1 to 3, where H of R is equal to negative 5.